Hello, welcome to LeetCode Solver. Today we are going to solve 14th problem in May LeetCoding challenge, and the problem name is Implement Trie. Implement a trie with insert, search, and starts with methods. Well, trie is a well-known data structure which is also called prefix tree, and example given here are initially we will initialize new trie, and we will call a method in trie with insert apple. Then we will search apple, returns true. Yeah, apple is the word apple is there, and then after search app, return false because we are searching as a whole word, but this is a prefix. And when we starts with method, call to the starts with method, which will basically look for the prefix and returns true. And when we insert another app word in a trie, then we have two words apple and app. And when you search for app, it will return true because app as a whole word is present in the trie. You may assume that all inputs are consistent with lowercase letters A to Z. All inputs are guaranteed to be non-empty strings. Okay, nice. So the trie in trie prefix tree, what we do is it is kind of a linked list, which is basically maintaining information like it is the consist of one information which will have first information can be any value or any information will be there, and second information will be the bunch of links for the next characters and the next, yeah, letters. Well, say for example, if we have words like app and abc, then first of all, if we want to build a trie, then first of all we have the first head node is something which will not have any value information, but it has a link information which will connect to a. So it has a link to a. So now a have its information which is a itself, its character information, and a will have link of other, like let's we insert app, then a will have a link which connect to p. So the p connector will be there, and this is another linked list which will contain p as a value and other links, and it contains the link to p. So now we have another list, another uh, linked list node which have p, and it doesn't have any further information because it is the last node. So link information here is empty. So this is what the trie structures looks like if we insert app. Now if we're gonna insert abc, then what happens is that this is the first node, and it will looks the link for a, and it found there is a links for a, and it goes here. And if we want to insert next time we want to insert b, and it looks for is there any link available for b in particular node. In this linked list node, we see that there is no any link for b. There is a link for p but not for b, so it create another link over here, another link in the same node which will for b. So now we have another link for b, and this node may have several link. So now this link this node have another one link for c, because that after the, b we want to insert c. So let's add c over here, and same thing after c we don't have anything to add. So it looks like this. So in this way we can form a trie, which is nothing, just a collection of just a tree structure. First element, first part being the value needed, like character or something like that, and the second will be the um, a list of collection of uh, links uh, which will point to the next try node with the uh, for particular character from starting from that particular point. Well, so let's implement our logic so as I mentioned, uh, the formation of try is quite easy. We just have to iterate over the links, and if we do not find any links, we have to build a new link, and we have to go through this. So now let's see how we can represent that particular try node. So let's build a class for try node, which will have what it can have. It can have information of particular character. So what information it can have? We can either store character or not. So it's let's store for now, and we can, as we have to know whether the particular try node is end node or not. So we can maintain a boolean over the information to find out whether the particular try node is end node or not. Is end, and let's have a constructor. Empty constructor without anything, and let's have another constructor with the which will accept character as a C and assign character equals C, and by default if we initialize character we will make default is end as a false. So this is not end of the try node, end of the word itself. Well, we define a try node in this manner. Well, it doesn't matter whether we store particular character or not, but we need to store another information for links. So let's maintain, we need to know for each character from that particular point where is the next pointer located, so that we have to access another try node. So it is a kind of map. So let's represent as an unordered map, which will find a character for every character. It will find a pointer for another try node, not trie node, try node. Say next, it will find the next one from that position. Maybe links this node to link to that character. Okay, let's links or link links. Okay, links. Now what is missing? Now let's we have to have a head trie node, every time we want to iterate we need to have maintain that information. So let's maintain trie node head, and let's initialize. When we initialize trie, head will be new trie node, which is basically this trie node from which we will initiate our links, so which doesn't have any information, but it has links only as a first, being a first head of the trie node. Well, in the initialization we can do that. And what, let's insert. In the insert, what we can do, we can iterate over the starting from head. So let's maintain a pointer of say p, which begins from the head, and for every character ch in word, we will insert into the trie only if we found that from particular position, from particular node, if we access its next, the link, if we access its links and link of that character, this is the current node, head node, and from that character the links to ch is missing. If it is missing, so also we can say, as this is a map, so we can have a count method over there. So if count is 0, that means it is missing, link is missing. So let's create any links of that character will be new trie node initialized with particular character. Otherwise we will have a link, so we will go through that link, or in any cases we form a link, so we will go to that link. And after insertion, if we insert every character, the last character, the pointer points to the last character finally, and for that last character we will make is int as a true. Okay, by default is int is false here when we initialized trie node. Okay, we inserted the words. Now let's search for the whole word. So it is also similar, like just iterating over the pointer, initially points to head, and for every character ch in word, what we do, if we find that the link is not accessible, links of count ch is 0, then we say that false, we can't find a word over there. Otherwise we will just make changes to the next links from current node taking ch character, and if we reach up to this, that means the word completed, the word can be accessed in the trie node. But whether when we finish the word, whether it is the last word in some of the trie word, that can be found if we check to the isn't variable in a trie node. So we can simply return p these pointers is int variable. If that is int, we will return true, otherwise false. Well, starts with is also similar approach. Try node p equals head prefix. What is the difference? The difference here is we will not check in the final position, we will not check. This is internet. In every case, we will return true if we can access out to that. So if we any case like link is missing, links dot count cs, because links is another map which contains count method. So if we do not find link for the character ch, then we will return false. Else we will move to the next character through the link. And finally, if we can do this, that means we can easily reach to the end of the prefix given prefix word. So let's return true. Let's compile the code. C equals user identifier ch. Oh, okay. Actually, we do not need character as well, as we are not holding ch. Now we are only holding isInt, and the links itself define the link to the character. So we do not need to maintain that character particularly. Okay, link ch. Okay, that can be mentioned, but we do not need to mention ch. We do not need to hold the character itself for this particular problem. Okay, let's run the code. Compulsion cannot be constructed be redeclared. Okay, we declared 2 times. Okay, awesome. Let's try to run. Okay, let's try with the custom tests. Okay, it's difficult to formulate custom tests. Let's submit and see. Well, accepted. And let's discuss about the time and space complexity of the problem. If we think about the time complexity of the problem, we see that every time the time complexity of insertion is the length of the word times we will iterate. We are not, the operation we did is constant operation, and for the searching as well as the length of the word, and for starts with length of the prefix. So these are the complexity of every methods we have implemented. Yes, and now let's talk about what is the space complexity. So as we can see that for every character, in the worst case, like for this, I mean for every particular position, we are the for first position letter everywhere, either we have same memory or we have to have another memory. If this is not same, like it was T instead of A, then we had to maintain another node over here. and if it is the same, if first node is same, suppose, and in the second node if it is different, then we have to maintain different memory over there. So let's assume that in the first place everything is different, in the second place everything is different. So in the worst case, if we have the bunch of words like this, then the worst case complexity will be uh, the total number of letters, worst space complexity, total number of letters, I mean summation of all the letters in the given insertion. This is the space complexity. So thanks for watching the video. Hope you like it, and if you want to see similar video in the future, please feel free to like, share, and subscribe. And if you have any comment or any alternative solution, please feel free to comment. Yeah, see you in the next video. Have a nice time.